Hi everyone, our group's going to be discussing 3D printing today, or additive manufacturing as it's more commonly known in industry. Let's start with a video from Austin exploring 3D printing here at Notre Dame.
Hey everyone, my name is Austin Thomas. We're here at the University of Notre Dame's Idea Center. We'll be working in the Innovation Lab where they have lots of 3D printers. 3D printing has a lot of wide uses, specifically with prototyping, which has made it cheaper and a lot more efficient, and also with medical devices. Let's go in and check it out. Our first step is actually finding a 3D component. I went on the internet and I found this cool owl that I like to print. I found the design and I brought it over to this 3D software that's on the left-hand side here. This is an image rendering software that does a time-lapse build of the product from the bottom to the top. As you can see, the product continuously goes along. We can break it down into multiple subsets. So as we bring it back into the center, you can see that the orange represents the internal working lattice that serves as a support structure, and the exterior is that blue that's noted. Now that we have our computer-aided design, it's time to bring that design to real life. What better way to do that than with an FDM printer? FDM stands for Fusion Deposited Model. What we have here is plastic material that's going to be heated up and posed from this spool right here into the main machine. What this does is it acts just like a 2D printer. It prints the interior and the exterior, and then it moves up a slight centimeter and continues the process. Here at Notre Dame, we have a lot of options when it comes to 3D printing. Two of the brand new ones are these two FDM printers. As you can see, this one with a 2 foot by 2 foot by 3 foot diameter is able to make much larger machines than the previous one that we're working with. Moving down the line, we have another type of 3D printer. This is a DLP, digital light processing printer. What this actually does is, inside of these machines, you have multiple different nozzles that are going to increase the liquid down onto the platform, and then use an ultraviolet light to actually harden that process. It's a little bit different from the FDM that we're using, but there's pros and cons to both.
Let's quickly look at how 3D printing is different from the traditional manufacturing processes. 3D printing, or additive manufacturing, is the creation of objects through the addition of material, usually layer by layer. This is different from subtractive manufacturing, the industry norm, which is the shaping of objects by removing material from solid blocks through cutting, drilling, and grinding. Value from 3D printing can be seen on both the bottom line and top line. In terms of cost, firms need less raw material to produce products. 3D printing can also simplify their supply chains by allowing them to create products more locally. This reduces production lead time, or the time from an item's order to its production and delivery. Overall, the cycle times are also quicker because product creation takes less time. In terms of top-line boosters, the improved product quality and performance can allow firms to charge more for their products. We're seeing many exciting use cases pop up early from 3D printing. A few include the development of buildings from on-site soil, which could be common as space travel continues to evolve. 3D printers have now grown to the size where companies can actually produce small cars like race cars, which we've seen the first fully 3D printed race car in Formula Group T. And finally, maybe the most impactful is the use of 3D printing for medical applications. Specifically, prosthetics and dental implants have started to take off, and organs are soon to follow.
Our two examples using 3D printing to drive innovation are General Electric and Volkswagen. Both are established industrial manufacturers, GE's aerospace division specifically providing components to the aircraft industry, and Volkswagen manufacturing consumer vehicles. In 2019, GE Aerospace held 16% of the jet engine market. Their addition of 3D printing into their supply chain has allowed them to reduce costs, simplifying their production cycle, while offering consumers more durable products by manufacturing them with fewer individual parts. An example of GE's innovation in 3D printing was the development of the LEAP fuel nozzle. By creating this jet engine part with 3D printing, they were able to reduce the parts involved 20 times while drastically reducing cost, weight, and inventory. Despite these reductions, the part itself was made 5 times more durable than one made through traditional manufacturing processes. Volkswagen has invested heavily in 3D printing, in the production of both automotive parts and the tools used to install and maintain them. The introduction of this technology has led to improvements in processing time, but more importantly has allowed Volkswagen to improve the quality of replacement parts and allowed the fabrication of tools and parts from previously unavailable alloys. Volkswagen's most recent triumph with these new alloys was the development of the largest brake calipers ever designed for a production car, the Bugatti Chiron. Printed from titanium alloy normally used in aerospace fabrication, these calipers provide record-setting strength while also reducing weight by 40%. By designing them specifically for the 3D printing process, engineers were able to bring the new calipers from the idea phase to production in less than 3 months, well below initial expectations.
While GE and Volkswagen have traditionally competed in very different spaces, the investment in additive manufacturing is pushing both companies into new sectors. Volkswagen's Audi division is moving into the aerospace realm with designs for lunar rovers to be printed and assembled while in space. GE is marketing their 3D printing technology to international auto manufacturers as a way for them to catch up with frontrunners like Volkswagen. The common thread is the investment in industrialized additive manufacturing, which could see these two industry leaders and other familiar names competing in new markets with developments gained through 3D printing. Thank you.